Hey everyone and welcome. Let's jump right into this explainer. Today we're unpacking a massive, incredibly complex climate event that is set to drastically shift the weather across India in 2026. We're talking about a phenomenon that's going to literally redraw the weather map, bringing intense, starkly different realities to different corners of the country. So get ready, because understanding this is absolutely crucial for everything from our food supply down to our daily commute.
Now you might be wondering, and this is the big question we're tackling today. Why on earth are we looking at forecasts that predict scorching, parched droughts in the northern states, while at the exact same time, the southern coast is bracing for sudden, torrential urban floods? I mean, how can one country experience such wild extremes simultaneously? Well, the answer actually lies thousands of miles away, right in the middle of the Pacific Ocean. To make sense of this all, here is our quick roadmap. We'll start with the El Niño phenomenon. Look at this tale of two extremes, track the agricultural shockwave, examine urban heat and health, and then finally, discuss strategies for resilience.
Okay, Section 1, the El Niño phenomenon. Let's take a look at what's actually happening out in the ocean to trigger these massive shifts.
Normally, you have these equatorial winds that gather a warm water pool toward the west. But during an El Niño year, those easterly winds weaken. And what happens is that massive pool of warm water just sloshes back eastward towards South America. This shift in the ocean's heat completely rewires global atmospheric pressure. Climatologists call this the Southern Oscillation, which in turn effectively suffocates India's normal monsoon cycle.
Now, an average El Niño is disruptive enough on its own, but a super El Niño? That's a whole different beast. This happens when sea surface temperatures in the Central Pacific exceed 2 degrees Celsius above the historical average. 2 degrees might not sound like a lot to us, but for the ocean, it's absolutely huge. Current forecasting models show anomalies that could push past 2.5 degrees this year. And historically, events of this magnitude, like what we saw in 1997 and 2015, create catastrophic global weather disruptions.
Moving on to Section 2, a tale of two extremes. Let's see exactly how this global oceanic shift translates into extreme weather over the Indian subcontinent. The geographical impact here is starkly divided. Up in the north and central regions, we're talking places like Punjab, Haryana, Rajasthan, and Madhya Pradesh, we are seeing high drought risks, with prolonged dry spells and searing heat waves. But conversely, the coastal southern cities, particularly Chennai and Tamil Nadu, face the exact opposite threat. They're looking at intense, sudden bursts of rain that can lead to severe urban flooding, much like the devastating floods during the 2015 Super El Niño.
To put some hard numbers on this national picture, the India Meteorological Department forecasts that this year's southwest monsoon rainfall will only hit 92% of its long-period average. So that translates to about 800 millimeters of rain instead of the usual 870. Because of this drop, the probability of a deficient, drought-like season has completely skyrocketed to 35%. That is more than double the normal historical risk.
Let's move into Section 3, the agricultural shockwave. Because with 60% of Indian farmers relying entirely on the monsoon, a deficit of this scale has some massive implications. If we look at data from the Indian Council of Agricultural Research, it paints a pretty clear picture of historical vulnerability. During past El Niño years, like in 2002, 2004, and 2009, 77 districts experienced a drop of over 10% in paddy yields, and 65 districts saw a similar drop for maize. Other really important crops like sorghum and pearl millet are equally vulnerable to these dry spells.
But you know, what happens in the fields doesn't stay in the fields. It creates severe economic ripple effects for all of us. A failed crop means lower income for rural households. That leads to a reduced national food supply, which inevitably causes a spike in food prices and inflation. High food inflation then forces the central bank and the government to adopt tighter monetary policies, which slows down broader economic growth. So we're literally all going to feel the heat of El Niño right in our wallets.
Bringing us to Section 4, urban heat and health. Transitioning from the rural economy to our concrete jungles, let's talk about the direct impact this has on human lives.
Extremely hot, dry conditions in cities are magnified by what's called the urban heat island effect, where dense concrete actually traps the heat. And this isn't just about feeling sweaty or uncomfortable. It's a real public health emergency. Extreme heat leads to heat stroke, dehydration, and respiratory stress. On top of that, these abnormal weather patterns create perfect breeding grounds for vector-borne diseases like dengue and malaria, while the broader environmental dryness dramatically increases the risk of severe, highly destructive forest fires.
But hey, it's not all doom and gloom. Here is Section 5, Strategies for Resilience. We actually have highly effective dynamic strategies that we can deploy to mitigate these extreme effects.
First off, on the agricultural front, the government isn't just sitting idle. They're actively rolling out contingency plans. This involves distributing drought-resistant seed varieties and urging farmers to pivot to short-duration crops, things like pulses, certain millets, and vegetables. Because these crops mature faster and require way less water, they act as a fantastic, practical defense against erratic rainfall.
And for our cities, the most exciting solution is GBI, Green and Blue Infrastructure. To make these concepts clear, we wanted to make learning about this as colorful, pleasant, and more attractive with image representations and animations as feasible, so you can really picture these nature-based urban solutions. We're talking about bringing beautiful, soothing nature back into our concrete environments to act as a vital heat buffer. Think urban forests, green walls, and restored wetlands that cool our cities through vital shade and a natural process called evapotranspiration.
Just look at the tremendous cooling power of these solutions. Studies show that botanical gardens can actually lower local temperatures by an impressive 5 degrees Celsius. Urban wetlands offer cooling of up to 4.8 degrees, and just adding street tree canopies drops the heat by nearly 4 degrees. This doesn't just make our streets look nicer. This natural shade can actually cut household air conditioning energy use by up to 30%. Literally adding just 5% more tree cover in a neighborhood can drop the temperature by a full degree, which drastically reduces heat-related mortality risks.
Ultimately, surviving a super El Niño, or really any major climate disruption, is all about community. We are happy if we are healthy, and the people around us are too. Our personal well-being is just so deeply tied to the health of our environment and our society. We've got to look out for one another and embrace these green strategies together. Awareness is the very first step to resilience. Please like, share, and subscribe if you wish for a healthier friends in society. If you do so, only then will we reach more people and create more awareness. If you want any specific topic covered in our upcoming explainers, please comment below. We really want to keep building this knowledge base with all of you. Which leaves us with one final vital thought to ponder today. The science is clear, the forecasts are set, and the green cooling solutions are completely within our grasp. But will our cities and our communities plant the seeds of resilience today before this extreme weather becomes our permanent reality? Thank you so much for exploring this with me, and stay safe out there.